Hey, good morning, guys. Today we're going to take a look at section 3.2, which is going to deal with quadratic functions. So last class we were talking about linear functions, so all the x's were to the first power, and today we're going to talk about quadratic functions, so all the x's will be to the second power. Okay, so that's a quadratic. So a function is quadratic if its equation can be written in the form ax squared plus bx plus c. So it has to have the x squared part to be a quadratic. So that's why it says the a cannot equal 0, because if a was 0, then the quadratic term wouldn't be there. Okay. All quadratic functions are transformations of the parent function f of x equals x squared. So we talked about this a little bit in chapter 2. The graph of a quadratic is called a parabola. You guys are familiar with that. This right here is called the standard form or the general form. We're going to talk about this here in a minute. You can also have what is called the vertex form, and we'll talk about that a little bit today as well. Vertex form is flat out a straightforward transformation of a normal parabola. So here's x squared. You can see the x minus h squared, so that's going to shift the graph horizontally. You're going to see a plus k over here. That's going to shift the graph vertically. And what it does is it moves the vertex to the point hk. So that h and that k are going to be your new vertex wherever you moved it to. And then the a could stretch it or it could like flip it. Now, now this is where I just talked about being transformations. All right, so the a, in both of those equations, that a right there or that a is important, okay? Because it tells us about what is called the end behavior of the graph. If a is positive, then the ends of the graph are going to be going up towards positive infinity. And if the a is negative, then the parabola is going to flip upside down. And so the ends of your graph are going to be headed towards negative infinity. Okay, you're going to hear me talk a lot, not so much today, but the next lessons about what is called end behavior. Okay, so end behavior means as your x's are going to infinity, what is your graph doing? Are both the ends going to infinity in the y direction, or is it flipped and it's going to infinity in the to negative infinity in the y direction? Okay, all right. So this is the standard form of a quadratic. Now, looking at a quadratic like this, so x squared minus 2x minus 3, what does that equation right there tell us about the graph? Well, our a is 1, positive 1, so that means this graph is going to open up. The graph opens up. Let's see. If I plugged a 0 into this function, okay, so when x equals 0, that will be 0, that will be 0, and I will be left with negative 3. So when f is 0, I get negative 3 as an answer. That means that the negative 3 right there is a y-intercept, which I could write as a point, 0, negative 3. So there's something about the graph. I know that this graph goes through the y-axis at negative 3. It's always the number on the end when you're in standard form, just like when you're in slope-intercept form. That constant on the end, that's your y-intercept. All right, now the x-intercepts occur when the function is equal to 0. So when you plug in a 0, that answer you get is your y-intercept. But when the function equals 0, that's your x-intercept. So let's take a look at this function and let's set it equal to 0 and let's solve this equation. Well, I'm going to need to factor this. So x, factors of negative 3 that add up to negative 2 are going to be minus 3 and plus 1. So the solutions to this equation would be x equals positive 3 and negative 1. So positive 3 and negative 1 are the two inputs that give us 0 as an output. So those are our x-intercepts. So 3, 0, and negative 1, 0 are the x-intercepts of this graph. These two numbers, 3 and negative 1, are also called the zeros of the function. And you're going to hear that a lot in the next section that's coming up. When we talk about zeros, what it means is what are the numbers that when I plug in, they make the function equal 0. So it's just a fancy way of talking about the x-intercepts, okay? So if I plug a 3 into that function, I'm going to get 3 squared minus 2 times 3 minus 3. Well, that's 9 minus 6 minus 3 is going to be 0. If I plug in a negative 1, I'm going to get negative 1 squared minus 2 times negative 1 minus 3. Well, negative 1 squared is 1. That minus 2 and that negative 1 multiplying together are going to give us plus 2. So 1 plus 2 is 3, minus 3 is 0. Okay, so those numbers, 3 and negative 1, which are our x-intercepts, are also called the zeros of the function. If you look over here in this box, it says in working with quadratic functions, the terms solutions. So what are the solutions to this equation? That's the first thing I did. I said, let's solve this equation. The solutions, the zeros, they're also called the roots, and the x-intercepts are all equivalent. All of these words really mean the same thing. Okay, so let's take a look at what we've got so far. We know the graph opens up. We know the y-intercept is negative 3. We know the x-intercepts are positive 3 and negative 1. And so with that right there, I could probably make a sketch. Now, this is not the vertex. This is not our low point. Okay, our vertex is going to be, parabolas are always symmetric. Okay, so it's going to be, we're going to talk about this here in a second. Okay, but it's going to be over here somewhere. Okay, so if I was going to sketch a parabola, come down, turn around, and that. Okay, so this standard form told me which way the parabola opens. It tells me what the y-intercept is, and then if I factor that, I can also tell what the x-intercepts are. Now, this vertex down here, you can find one of two ways. First off, there's a formula for it. Okay, from standard form, h, so again, there was this hk, that's your vertex. H is negative b divided by 2a. So that's this right here. So negative b, so that's our b, and then our a is the number in front of the x squared right there. Okay? So negative 2 would be 2 over 2 times a, but a is 1, so it's just going to be 2. So our h value is just 1. Okay? Now, how would you find the k value? How would you find the y associated with that x? Well, you would plug it in. If you plug in the x value of 1 and solve this, so that's going to be 1 minus 2, so now we're at negative 1, minus 3, now we're at negative 4. So the point 1, let me put my parenthesis here since I did some more math, 1, negative 4 is going to be our vertex, which is pretty close to what I approximated here. This is 1, 1, 2, 3, 4. Okay? Another way is this. Your vertex is always going to cut your graph in half. Okay? Parabolas are symmetrical. So, if you take these two x-intercepts and you average them, okay, this is a 3 and this is a negative 1. Okay? If you average them, 3 plus negative 1 divided by 2. That's the x value of your vertex. Your vertex has to be right smack dab in the middle between those two x-intercepts. And sure enough, 3 plus negative 1 is 2, and 2 divided by 2 is going to give us 1. So again, there are two different ways. There's a formula, or there's just thinking through and going, I know where my x-intercepts are, let's just average them, and then that's going to be the x value of my vertex. Now, you still have to plug that in to find the y value, but that's one way of finding the x value. All right, so let's take a look at the back here. Now, at the very top, you're going to see different forms of a quadratic. So this is the vertex form. This is called standard form. We talked about that. And then there's factored form, which is just taking standard form and then factoring it, okay? Now, each of these has its own things that it can tell you about the function. So like vertex form, or about the graph. Vertex form, the A out front will tell you whether the graph is opening up or down. Okay, the H and the K are the vertex. Now remember, what you're going to see is minus H, and this is just regular H. So remember, it's always the opposite of what you're seeing in the parenthesis. That's going to be the X coordinate of your vertex. Now, standard form, again, tells us whether the graph's opening up or down. The C tells us the y-intercept. And then we can always find the vertex either by using this formula, or if we know the x-intercepts, we can just average them. Well, factored form tells us the x-intercept. So if we've got it factored, which the ones that we're going to do, they will be able to factor, we're going to take standard form, we're going to turn it into factored form. So not only do I know the direction and the y-intercept, I'm also going to know the two x-intercepts as well. Okay? And then we can find the vertex either with the formula or just by averaging those two x-intercepts. So, for example, the first example I give you is in standard form. So, looking at this, does the parabola open up or down? Well, that negative out front means that it's going to go down. Okay? Is the vertex a local maximum or minimum? Well, if you've got a parabola that's been flipped upside down, that vertex is going to be a high point, and then you're going to turn and go back down. So that is going to be a local maximum. Okay, so you're going to hear me use a lot of the same language we were using in Chapter 2. We're going to talk about maximum and minimums. We're going to talk about where is the function increasing or decreasing, things like that. Okay, we're going to talk about domain and range. All right, so it opens down. That means the vertex is a local maximum. All right, what is the y-intercept? The y-intercept is 8. So 0, 8. X-intercepts. Well, for the x-intercepts, we need to factor this. And this one involves a little trickery. I'm going to say that's a word. All right, so first off, whenever we factor, we always want our x squared to be positive. So the first thing we're going to have to do is we're going to have to factor out a negative. So we're going to factor a -1 away, like out of all these terms. So now I have x squared, I have plus 2x, and now I have minus 8. Okay, so the -1's going to stay there, and then I'm going to factor what I have left into two sets of parentheses. So x squared is going to be x and x. Factors of -8 that add up to positive 2. So factors of -8, probably 4 and 2. So 4 times 2, but one of them has to be negative. I want, when they add together, I want them to add up to be a positive 2. So I'm going to say plus 4 and minus 2. 4 times -2 will give me my -8, and 4 and -2 added together will give me my positive 2 in the middle. All right, so my x-intercepts are going to be -4, 0, and 2, 0. Let's see, what's the vertex? Well, again, there's two ways to find the vertex. The x-intercept of the vertex is either -b, so -2, or 2, divided by 2 times a, which is a -1. So it's going to be 2 divided by -2, or -1. We also could have just added these two together. -4 plus 2 is -2, and divided by 2. Average your x-intercepts, and you'll find that x-coordinate of your vertex. Now, I need to plug that -1 into this equation to figure out the y value of the vertex. All right, where would be a good place to do that? I'm going to do it right here. Negative, and then -1 squared minus, okay, minus 2 times -1 is going to be a plus 2. I'm going to go ahead and simplify that, and then I'm going to have a plus 8. All right, so -1 squared is 1, positive 1. But there's a negative out front that's going to make that negative. So this is now -1. When you simplify all this, it's -1. Plus 2, that's going to be positive 1. Plus 8 is going to be positive 9. So this is my vertex, -1, 9. I've also got a question about the domain and range. Well, now that we know the vertex and we know the y and the x-intercepts, let's go ahead and graph this thing. So vertex is, and you could do this in any order, Okay, so the vertex is negative 1, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's your vertex. There's a y-intercept at 8. My x-intercepts are at 1, 2, 3, negative 4, and 1, 2. That's enough. Know that this vertex, everything's symmetric. So if you go down that way, you could also go down this way. And that's our parabola. Okay? Domain is always going to be all real numbers. What's the range? Well, because this got flipped, this graph is heading towards negative infinity. So the range would be everything from negative infinity up to 9. Okay? Oh, I just made a mistake. Did you catch it? 9. Okay, we want to include the 9 in our answer. You could also say it's all y's that are less than or equal to 9. You could write it that way. Where is this function increasing and where is it decreasing? Okay, we've talked about that before. This graph is increasing from here to here, and it's decreasing from here to here. Now, this is tricky. When we talk about increasing and decreasing, we talk about x values. So, this graph is going towards negative infinity in the x direction. Okay, so it is increasing from negative infinity up to what? And the fact that I just said up to, we have a tendency to look at how high it is. But remember, we're focused on the x value. It is increasing from negative infinity to negative 1, the x value. Parenthesis. And then it's decreasing from negative 1 to infinity. Negative 1 to infinity. Okay, it's very easy when you say it's increasing to look at the y value instead of the x value. We're talking about x values here. It's very easy to look at that arrow that is pointing straight down almost and saying, oh, it's going to negative infinity. But it's going to the right, ever so slowly, but enough to where it's going to positive infinity, not negative infinity. Okay? All right. Next example is in vertex form. So let's see what this tells us. So the vertex is at positive 1, negative 4. And that's really all we have. We know the vertex is at 1, 1, 2, 3, 4. There's my vertex. We know that that 2 right there means that this graph opens up. It's also getting stretched by 2. Okay, so our normal parabola, where we go over 1, up 1, is going to go over 1, up 2. Left 1, up 2. You could keep going with that. You could go over 2, up 8. Okay, normally when we square a 2, we get 4 as an answer, but everything's going to get doubled. So you would go up 8, and you would get a parabola that goes like this and like that. Now, we don't know the x-intercepts by looking at this. We also don't know the y-intercept. It's very easy to look at that negative 4 and think that that's a y-intercept. To find the y-intercept, you would have to open up, you'd have to take the x minus 1 and square it. You'd have to open up those parentheses. You would then have to distribute that 2 into the parentheses. And then you would have to simplify the constant that is in the parentheses with that minus 4 right there. And that would give you your y-intercept. Okay, so when you're in vertex form, the only things you know are the vertex and whether this graph is opening up or down and whether it's being stretched. So this is just a straight transformation. Okay, graph of parabola that's been shifted right 1, down 4, and stretched by 2. Now, once we're looking at it, we can tell the domain. We can tell the range. Looks like it would be all y's that are greater than or equal to negative 4. Where's the function increasing and decreasing? Now this one, it's decreasing over here, so it's decreasing from negative infinity to, remember it's that x value, to 1. And then the graph is increasing from 1 to infinity. Increasing from 1 to infinity. Remember, parentheses. All right? All right, last thing we're going to talk about is how to solve an inequality given a quadratic, okay? So what x values would make x squared minus 4x minus 12 less than or equal to 0? All right, so here's what we're going to do. We're going to graph this thing. This is in standard form, so I can tell the y-intercept, is negative 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, it's down there. I could factor this. X. Factors of negative 12 that add up to negative 4 are going to be negative 6 and positive 2. So my x-intercepts are positive 6 and negative 2. So 1, 2, 3, 4, 5, 6, and 1, 2. All right, so I got my y-intercept, I got my x-intercepts. If you wanted to know your vertex, what did I say? 6 and negative 2. So 6 plus negative 2 divided by 2 would be, well, this is 4 divided by 2. And then I'd have to plug that 2 in to figure out what the y value is. Well, x squared is going to be 4, minus 4 times 2 is going to be minus 8, and then minus 12. All right, 4 minus 8, we're already at negative 4, and then minus 12 is at negative 16. So we are way down here, okay? But all I need is an approximation for this anyway. What I really need to know is where those intercepts are, okay? So let's go back and let's look at the question. Where is this graph less than or equal to 0? Where is the function less than or equal to 0? We did that last chapter. Everything from here to here, the function is below the x-axis. The function is negative, which is what less than 0 means. Now on this one, we also want equal to 0. So we want everything from negative 2 to positive 6. So the interval from negative 2 to positive 6, including the negative 2 and the 6, would be the solutions to that inequality. All those numbers work. You could also say everything from negative 2 less than or equal to x, which is less than or equal to 6. All the x's that are between those two values create function values that are negative. That's it. That's all it is. Okay? So this one, where is x squared plus x greater than 12? Okay, let's not do that. Let's do x squared plus x minus 12 is greater than 0. Okay? We need to use 0. We need to know, we need to differentiate between above the x-axis, below the x-axis, and not above or below 12. That's confusing. Okay? So let's just solve this. Again, I'm going to figure out my x-intercepts. X factors of negative 12 that add up to 4 are going to be plus 4 and minus 3. So my x-intercepts are 1, 2, 3, negative 4, and 1, 2, positive 3. Now for this problem, this is really all we need. I also know there's a y-intercept down here at negative 12 again. Okay, all I need is a sketch of this graph. Something like that. Okay, it's not perfect, but something like this, because I need to know where is the function greater than 0. Well, this branch of the parabola has values greater than 0, so that's everything from, let's say, negative infinity up to, what do we say that was, negative 4? Now, this is strictly greater than, so we don't want the negative 4. That's just our stopping point. And then we also want everything from, so this is all negative, 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 and then right here at 3 to infinity. That's the solution to that inequality. It's every single value from here to here and also from there to there.